would recommend, when I say 45 degrees, I mean this angle right here. I would make that angle about 30 when you're drawing this set of axes. So it says point -1, -3, -3. So what does that mean? So if I'm at the point, whoops, if I'm at the point -1, -3, -3, where am I going to go? How far back do I go first? I go back 1. I then go to the left or right. Well, how much? Left 3. So 1, 2, and 3. And then how far down do I go? 1, 2, 3. So this is the point -1, -3, -3, right there. So I'm at that point right there. Fantastic. Nice. I plotted it. The x-axis is perpendicular. Very good. So if we went back on the x-axis, we were behind the yz plane. So it says we are facing the yz plane. You walk 2 units forward. So if we walk 2 units forward, so 2 units forward, so we are facing the yz plane. If we walk 2 units forward, what point are we going to be at? If we walk 2 units forward, 2 units forward.
Wouldn't you be at
X equals positive 1. Yeah, so you'd be at 1, -3, -3. Exactly. So we walk 2 units. You walk 2. That's a 1. Yeah, it's a 1. It just dragged. You walk 2 units forward, turn left. So if we turn left, what plane are we going to be facing all of a sudden? We turn left, so we're going to face the XZ plane. If we face the XZ plane, what axis are we walking on parallel to? The y-axis. So it says we turn left and then walk another 2 units. So we turn left. So that means we are now facing what? Facing the XZ plane. So if we're I'm sorry, I'm having trouble writing today. If we're facing the XZ plane, we walk 2 units forward. Now where are we going to be? 2 units forward.
So it would only be 1 positive 2?
Nope.
I mean,
1, -1, -3. Exactly. Y increases. So because we're walking to the right 2 all of a sudden. What is your final position? So our final position is right here. 1, -1, -3. From the point of view of an observer looking at the coordinate in figure 12.2.2 on page 640, are you in front or behind of the YZ plane? So are you now in front or behind of the YZ plane? Are you in
behind it because there's 2 negative? Oh,
yeah. So let's see here. So what have we done here? First of all, I'm speaking. Thank you. I'm trying to set everybody else up here. First of all, we walked back and down. So we were in that like back bottom octant, right? Back bottom octant. So we walked forward 2. So we're now in the front left octant, right? And then we walked 2 to the right. Have we changed octants? No, because the sign of our y coordinate, we change octants when the sign of one of our coordinates changes, right? We went from this to this. Did any of our signs change? No, so we're still in the bottom left here. So the question was asking, are we in front of or are we behind the YZ plane? Where's the YZ plane? The yellow, right? That's the YZ plane. So are we in front of it or behind it? We're in front of it. Yep. 3. If you want to sketch all of the points where x equals -3, what are you actually going to sketch? A plane. The plane is going to be right there. So there's the plane. Where does it touch the axis? Right there.
So it's XZ plane?
It is parallel. So x equals -3 is parallel to which plane? The YZ plane. Correct. Yep. X equals -3 is parallel to the YZ plane. That's correct. That's not bad.
What about 9?
What about 9? Let's see 9. Note, I'm going to get better at this as we get more into this. The more lines you draw in 3 space, the busier it gets and the harder it is to see what's going on. So you see how I tried to do gentle shading there and it kind of made it look a lot worse? So if I draw just the outlines of these things right here, let me try drawing this again. I'm going to try drawing this one more time. So if I were to draw this, I drew those points and I drew too many things there. If I just draw this much more simply, it theoretically should look better. So if I draw, there's that plane right there. And then I draw the next plane, which is going to be something like this. Something like this, if I can actually get it to respond. Like that. Then where are they going to intersect? Right there. Sometimes the perspective, and also I didn't really draw those level, did I? So it just takes practice. That's one way these surfaces are awesome because you can do an infinite erasure, right? So let's draw this parallel actually. So here, oh, I wanted to do that same color. Try it again here. Try this. So we go here, if I can get this to respond, there we go. So there's z equals 2 right there. Looks like a little low, doesn't it? So it takes practice. Let's go up a little higher. Ooh, like this. That looks a little better. Then where's this one going to be? Maybe like right like this. So where do they intersect? They intersect right there. Does everybody see what I'm talking about? It just takes practice. There's this line. So they intersect in a line. They intersect in a line. Does that make sense? So again, how many different ways can a sphere intersect a plane? It can be tangent, so it intersects at a point. It could intersect not at all, or it could be like a cut, like a sector, like a cap being cut off, and the intersection would be a circle. Does that make sense? Yay. It's not going to be a 2-column one. It's going to be more of a grid. It's going to be more of a grid. So what could our grid look like if we were going to do this by hand? If we were going to do this by hand, we could have our x values and our y values. So 1, 2, I'll space it out a little more here. How about 1, 2, 3, 4, 5, and 1, 2, 3, 4. So if the x values go this way and the y values go that way, could you fill in each of those grid points? Sure. It's going to be 1 squared plus 1 squared is, oh, sorry. Sorry, it's 2, like that, right? So what goes here? 5, and then what? 10, and then 17, and then 26. So could you fill out? It's going to be 5, it's going to be 10, it's going to be 17, right? So then you get 2 squared plus 2 squared, so it's 8. And then you get 3 squared plus 4 squared. So could you fill in the rest of these? Yeah, you could fill in each of these boxes right here. So after you fill in each of these boxes, if you were going to do this by hand, you'd have to sketch it really carefully, right? Is perspective really hard to manage? It is, because if you change perspective a little bit, sometimes points line up and then you like lose them, or like the intersection line of two planes overlaps with one of the axes and then you lose it all of a sudden. If you were to do one of these by hand, you have to do it really, really, really carefully. You have to do it super, 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 super carefully. Are we going to do a lot of these by hand? Not that many by plotting points. Plotting points is actually a really ineffectual way to graph surfaces. And when I say surface, it doesn't have to be flat, it could be curvy. Graphing by plotting points is really, really hard. Izzy, you said something that was super important though. We're gonna much more often graph what instead? You said when you're graphing a line, for example, what was something you find traditionally? Intercepts. Intercepts are gonna be key here because intercepts could be points, they could be lines, or they could be curves. But if you have the intersection of a plane and the surface, that really, really helps you. Yes, Tamek?
I think for this graph,
Points? No. You're not going to plot a lot of points because plotting all those points is hard. I mean, look at the shading involved that you have to use. Like if you take away the shading, it loses all perspective and it's like impossible. It becomes impossible. So let's talk about this for a second here. What's going to happen in each case? Well, not too much that's different than what you have right now. So we know what x squared plus y squared looks like. What does x squared plus y squared, what's one word for it? What's that look like? It looks like a parabola. It's a parabolic bowl. It's a bowl shape, right? So what does adding 3 do to it?
it shifts it up.
It just shifts it up. The shifting and translating is all going to be the same. It just shifts it up. It just shifts it up. What's the relationship between h of x and our original function? So let's say this. Let's say f of x is right here. So here we go. So this one right here, here's f of x right here. Remember that it's f of x. So if I wanted to translate h of x into something a little bit more similar, that would be 5 minus what? 5 minus x squared plus y squared, right? So what's the relationship going to be between f of x and h of x if you graph it? What's going to be the relationship? It reflects, right? It's going to reflect. So it was originally going up. What's it going to do? It's going to face downward, right? And the whole thing is going to move up 5. The whole thing's going to move up 5. So if you did a really rough sketch of this, where's the top of this bowl going to be? Where's the top of this bowl going to be? 0, 0, 5. Remember how, I don't know, I and many other teachers might be annoyed at you if I ever ask you where a point is and you give a single number. It's even more important now because how many numbers describe a single point? 3. So what point did I label there? Can you tell me what point I'm trying to label? 0, 0, 5. And what does this look like? It's a parabola facing down. So I'm going to show you how I would sketch this. Whee! And it keeps on going down like this. Nice. So it's a parabola facing down. Parabola facing down at 5. What about this one right here? What happened here? What's the only thing that happened?
Shifted it over in terms of the y coordinate by 1.
Shift 1
in the y direction.
to the
Positive Y direction.
positive y direction. Yeah, that's exactly right. So all that does is shift it. So have you seen all these translations before on functions? In trig land, did you see it? Yeah, we're literally covering the same thing in calculus right now, just with trig functions, right? So nothing changes about the shifting here. Just knowing what you're starting with is the key. Because how many different things could you start with? A lot of them now. A lot of them, a lot of them. Okay, so the way we're going to do a lot of graphing is not by points, but by cross sections. If you draw the cross sections and connect them with wireframes, you can get an idea of what it looks like. So this right here is x squared plus y squared, right? If you were to cut it along the yz plane, what shape would you see? You'd see a parabola. And if you cut it along the xz plane, you would also see a parabola. So if you draw the two parabolas and then connect them with some circles, you get a basic idea of what it looks like. Yes, you look at cross section. Cross sections are planes. Cross sections are planes, like x equals 0, y equals 0, z equals 0. You make cross sections, and then what do you do with the cross sections? You connect them. Graph with cross sections. It's so much easier. It's so much easier. So once you draw all these cross sections, it's a lot easier to see what's going on. The second rule of sketching, I've already mentioned it once. Should you draw a lot of lines or a few lines? Really minimize it. Try really hard. It's going to be tempting to try to like shade everything in. You're going to get to a point you're going to look, it's going to look good, it's going to look a little better, and then it's going to look a little worse, and then you're going to have no idea what it is. Like it happens all the time. Be gentle. Be gentle. Be gentle with the number of lines you use. So do you understand what I mean by cross? Is when what is 0? It's when y is. It's when z is. It's when z is 0, right?
Are you doing xz or xy?
I'm sorry, I meant to say xy. Let's do the xy plane. The xy, this is informative. The xy plane is when z is 0. Everybody with me so far? So if that's true, what do we have here? X squared minus y squared is equal to 0. So that means x squared is equal to y squared.
The absolute value of x is equal to the
Ah, so the absolute value of x is equal to the absolute value of y. So let's put a pin in this one right here. Let's just keep this right here. And then look at the other. Let's look at the other two planes. So what's the next plane you want to look at? The xz plane? What's the xz plane? When y is 0. So in that case, what do we have? Z is equal to what? X squared. Oh, that's nice. Let's do one more here. The yz plane. The yz plane is when what is 0? When x is 0. So we have z is equal to? No, z is equal to, oh, yes, sure. Thank you. That's very important, that negative sign. Negative y squared. So here's the thing. Because you plug in 0 right there and you're left with negative y. Look at the original function. This is the function we're plugging into. This is the function we're plugging. Yes, g is z, the output, yes. Yes, z, g is z, correct. The output is z. Are you with me for these three things so far? Yes. Is everybody with me so far? Okay, so let's put these three things together and see what happens. So first I draw me some axes. Yay! Or I could have done the line tool, but I'm not going to. And I'm going to miss the grid line. That's fine. Like this. Exciting. Okay, so we have z, we have x, and we have y. So on the xz plane, everybody, so let's use this xz plane. Where's the xz plane? That's this one right here, correct? Is it this plane? I think so. I think it's that plane. On that plane, z is equal to x squared. So what do we get to draw? It starts here, and it's a parabola, the intersection. This cross section looks like this. Does that make sense, everybody? Is everybody there? Okay, so now, though, we have the yz plane. Where's the yz plane going to be? Yeah, it's like this one right here, correct? So what's that? Z is equal to negative y squared. I'll do that one in red. So it starts here, but where does it go? It goes down like this and down in the back like that. Is everybody with me? So those are the cross sections. So what the heck does this look like? What the heck does this look like? Ah, it's like a bent something. So what is it going to look like? It goes down like this, right? It goes down like this. I'm drawing the surface, everybody. Do you see the surface I'm trying to draw here with the wireframe? Does everybody see what I'm trying to draw here?
Yeah.
So what does it look like when you do it in a really nice program? It looks like this. It looks like a potato chip. So what do you have here? You have two different concavities here, don't you? Concave up and Oh yeah, so there's a really cool name. This is one of those cool points right here. See the origin right here? Along the XZ plane, so along the XZ plane, which is right here, along this plane, it's concave up, right? Sorry, along this cross section, it's concave up. But right here, it's also concave down. So at this point, the surface is concave up and it's what? Concave down. So remember I said two things can happen in multidimensional land, three-dimensional land. It can be an extension of what we had before or something new. Which one is this?
Something new.
This is something new. A point can be either concave up, concave down, or both, which is pretty cool. This is called a saddle point right here. This is called a saddle point. This is called a hyperbolic paraboloid. This is my favorite surface. I love this surface. It's elegant, it's awesome, and it's the first example of something new in multidimensional space that people generally see in multivariable calculus.
So wait, is that
I love it.
anywhere on that surface?
No.
Concave up and concave down? Because
Yes. Because look, right? Intercept. So the first thing some of you noticed was you started drawing planes, and you can draw planes, and then you can find out where it intersects each plane. That's absolutely something you can do. Another way to think about it too is you could find points. You can find points because what shape do you think this is? What kind of surface do you think this is? This is a plane. This is a plane. This is a plane. So how can we actually show that? Well, let's do it this way. Instead of the x, y plane, let's look at the x-axis, let's look at the y-axis, and let's look at the z-axis. What's true about the x-axis? That's when what is true?
when X is
Nope.
no,
Z is 0 and y is 0. So if x and z are both, if y and z are both 0, if y and z are both 0, you have 0 is equal to 1 plus 0. So what does x have to be? Negative 1. So the y-axis is when x is 0 and what? And z is 0.
So Y is also negative.
So y is going to be negative 1. The z-axis is when x equals 0 and y equals 0. So what's z going to be?
1.
Z equals, not 0, z equals what?
1.
1. So how many points do we have?
3.
So we have 3 points. What's that first point? So the 3 points we have are negative 1, 0, 0, 0, negative 1, 0, and what?
0,
0, 0, and 1. 0, 0, and 1. So what can you do with those 3 points? Plot those 3 points. So you draw your axes right here. Nice. Draw these. Draw these. Oh, nice. Okay, I'm doing okay here. Not bad. So we have z, x, and y. So we go oh, so it's like right here. Let's go back 1 like that. So that's the first point. That's point A. Where's point B going to be?
It's going to be
Is it to the left or down? Where is that? I think I just...
because it's to the y-axis.
On the y-axis to the left. So there's B right there.
No, left.
Oh, the other way. I went the wrong direction. Okay, thank you. The other left? Thank you. It's very good.
How do you erase the dot without erasing the line?
Go really, really, really slowly. Thank you for noticing my talent at erasing crap. Yes. 0, 0, 1. Do I go up or down?
You go down, up, 1.
Up to here. There's point C. So what do you do with those 3 points?
Drop planes.
Connect them. That right there is a triangular cross-section of this plane. Where does this plane extend? It extends up and out in those directions. This is the piece of the plane that we find most interesting. What's interesting about this is you see this line between B and C? What plane are we on for the line between B and C? What plane are we on for the line between B and C? We're on the YZ plane. So this segment right here is the YZ plane, right? The YZ plane is when what is 0? X is 0. So what was our original equation? Our original equation was z equals what? 1 plus x plus y, right? Correct?
Yeah.
So what equation do we have if we plug in x equals 0? If we plug in x equals 0, what do we end up with? Z equals what? 1 plus y. So what's the equation right here?
Z equals 1 plus 1.
That line is z equals 1 plus y right there. That equation is z equals 1 plus y. So could you find the equation of the other 2 lines? Yes, you absolutely could, because, for example, B to A, everybody, B to A, that's when z is 0. That's the xy plane. That's the xy plane. Plug z equals 0 in there. What do you get? 0 equals 1 plus x plus y. So y is equal to negative x minus 1.
So it's
So this right here, let me just finish it here. Hold on. This right here is, what's the equation for that one? X plus y is equal to? You can write it like that, equals negative 1. So could you find the equation for all of them? Yes. So some of you were actually trying to do this. You were finding the planar cross sections, or the planar intersections, these cross sections. You were trying to draw each of these separately and then connect them. If it's a plane, how many points do you need to draw a plane?
1,
3.
3,
3 points. How many points do you need for a line? 2.
2,
How many points do you need for a point? 1. How many points do you need for a plane? 3. 3. I like you to get the fist on it there. 3. So if you know it's a plane, find 3 points and connect them. The way you can think about this is a piece of plywood being leaned up in the corner of the room. Leaned up in the corner of the room. Can you see what I'm getting at?